the sound on so that you can listen to the lesson in the video. Feel free to pause as many times as you want so that you can write things down. So today's lesson is really just the beginning. We're really just practicing some vocabulary and combining like terms. So this top part, these notes, is just so that we understand and we're all on the same page with some of this vocabulary. So the first vocabulary word that we have is the term expressions. So an expression is a mathematical phrase that contains numbers, variables, and operators. An expression will not, oh, I don't want yellow. An expression will not have an equal sign. An example of an expression, I can put any example here. I could say 3x plus 4. That is an expression. It does not have an equal sign, which means we cannot solve this. The most we could do is exactly what it is simplify it. A term is a constant or a variable in an expression. Terms are separated by plus signs and minus signs. So in this example, we have 1, 2, 3, 4 different terms. I'm going to erase those because I know I covered up some of the writing. So these are the terms that we have. We have 6x. It's separated by a minus sign, right? So the next term that we have is 10y. That's our second term. Separated by a plus sign, so we have 13, our third term. Separated by a plus sign, we have 5z as our fourth term. The coefficient, the number in front of a variable is the term. Sorry, I just got interrupted. The number in front of a variable is known as the coefficient. So if we are circling all of the coefficients in this expression, 14 is a coefficient because it's in front of the variable. 7 is a coefficient. It's in front of the variable. 2 is a coefficient. It just means the word that is in front of the variable. The coefficient is being multiplied by the variable. So I think that's really important. So I am going to add that in here. Coefficient is the number being multiplied by the variable, whatever the variable is. So I think that's kind of important to put in there. So like terms, that's what we're going to be practicing. In order for terms to be like terms, they must both have the same base or variable and the same exponent or power. So we can say the word exponent or we can say the word power. It means the same thing. So that's what we're going to be practicing. We're going to be practicing simplifying expressions. First, we're going to practice what is a like term. So a like term, again, means it has the same variable or the same power. So if we are looking here at these boxes, we have negative 15x and negative 15. This one has an x. This one does not. So these would be unlike. Why did it do that? They would be unlike. But the next problem, we have a C here and we have a C here. So that means these terms are like terms. This might be a good time to pause the video and try some of the other problems on your own. All right, so hopefully you paused. Looking quickly, I'll go through these kind of quickly. So we have an x squared and an x squared. So those would be like terms. Next, we have a y and an x. So those are two different variables. Those would be unlike terms. These ones have no variables. So we could add or subtract those. Those would be like terms. B and B, again, more like terms. This one's a little tricky. They both have an M, but remember, a like term has to have the same exponent or power. So this 10m has no exponent on the left, but this 10m on the right is squared. So it has a different power, meaning these are unlike terms. The last one, an N, no N, so they are also unlike terms. So on this box on the excuse me, on the right, it's asking us to give an example of a like term. So I think I did one of them already in the notes. So I noticed that this one says b squared. There are infinite number of correct answers. I could say 3b squared is a like term. Or I could say negative 100. Doesn't matter. Any number as long as I have that b squared. It is a like term. No exponent means I would have no exponent again. So you can pick any number, 55. I could pick 17, right? I could pick 22. Whatever my favorite number is a like term here. So again, I think this is a good time to pause the video and try some of the others on your own. So since there are so many correct answers here, I don't really want to give a bunch of answers because I don't want you to think that you are wrong. But basically, for a like term to 14y, it can be any number as long as you have a y after it. Here, you can have any number as long as you have an x after it. I could pick 12, I could pick 13, I could pick a million. It doesn't matter as long as there's an x after it. So I can take a look at some of these when we are back together. The next page talks about now simplifying expressions. So we're going to use our knowledge of like terms to simplify expressions. We can simplify algebraic expressions by combining like terms. Be careful when combining to check the sign in front of the term. So looking to see if it's positive or negative. So in this example, I like this example because it does give us some pictures to go along with some of the math. So a group of friends went to the movies and bought the following. They bought some tickets, some drinks, and some popcorn. So let's take a look at what they bought. It looks like here they bought 2 popcorns. So I can write that as part of my expression, right? 2 popcorns. Plus, what else did they buy? Well, they bought a drink. So 2 popcorns plus a drink. Plus, what else did they buy? It looks like here we have a picture of 2 tickets. So plus 2 tickets. Then what else? Oh, they bought another drink. So plus another drink. Plus 2 more tickets in the picture, right? So plus 2 more tickets. Plus another popcorn. So we can just say plus P or plus 1P. Plus 2 more tickets. Oops, I'm just drawing the wrong letter. Plus 2 more tickets. So as you can see, our expression is getting really long to represent this. And then plus another drink. So when we are combining like terms, that's the point, right? We don't want to write this really long expression. what can we do to simplify it a little bit more? Well, we can combine the terms that are alike. So I really already color coded a lot of these, but basically I'm saying, okay, I can combine 2p plus a p. So what's 2p? What's these 2 popcorns plus this 1 popcorn? Well, I end up with 3 popcorns, right? What's next? They bought some drinks, so I can combine my drinks. So I have 1D plus 1D plus 1D. And as we can see in the picture, that translates to 1, 2, 3 drinks. So D plus D plus D would give us 3 drinks, 3D. And what's last? We have our tickets. So here I have 2 tickets, 2T plus 2T plus 2T. So 2 plus 2 plus 2 is 6T. And that makes sense in our picture, right? I can see that I have 1, 2, 3, 4, 5, 6 tickets. So we are done. We have combined like terms to simplify this expression. This is as far as we can go. There is no equal sign. We cannot solve this. So that's what you're going to be practicing here. We can do the first one together. Remember, we are only combining terms that are alike. So I can only add r's plus r's, add or subtract. So 13r plus 5r will give us 18r. There is nothing that I can combine with this 2n. So it's just going to be by itself as part of my expression. And we're done, right? That is done. That's as far as we can go. I think this is a good time to pause and try a few others on your own. All right, so let's see. Hopefully you tried a couple of these. I'm going to start by color coding. So I have a W. Be careful now, this is a minus a W. So that's important. I want to take that minus sign with it. And then this one is plus a W. So we're going to do 1.6W minus 1.2W plus 4.7W to give us 5.1W. And again, there's nothing that I can combine with this 3.5. It has no variable. It's just a constant. It's just by itself. So it's just going to be by itself in the expression. We can talk about how to enter fractions into the calculator when I return. So maybe I'll skip that one for now. But hopefully in number 5, you combined all of these because all of these have a B. So hopefully you did negative 18.7 plus 4b minus 0.2b to get negative 14.9b. Again, we have fractions here, so I'll skip number 7, or excuse me, I'll skip number 6. In number 7, we have a negative 1.2k, adding that to a 0.3k. So negative 1.2 plus 3 gives us negative, I like to put 0.9k. What else? I have this 3.9 has nothing I can put with it. Oh no, I'm wrong. It has a 7. There's a 7 over here. So 3.9 plus 7 would give us 10.9. And then we have a third thing that can be combined. We have this negative g plus 0.5g. So this negative g is the same thing as saying negative 1g. So negative 1 plus 0.5 is negative 0.5 g. All right, hopefully you got at least that far. We can try some of these others on Monday.